Much has been done to improve corrosion-resistant aerospace materials, such as improvements in materials, surface treatments, insulation, and protective finishes. All of these have been aimed at reducing maintenance efforts as well as improving reliability. In spite of these improvements, corrosion and its control is a very real problem that requires continuous preventive maintenance. One key to preventing corrosion is eliminating the electrolyte, usually in the form of water, from the equation. Each of the following processes is designed to do just that. Electroplating is a process of transferring metal from one object to another by chemical and electrical means. Tin, zinc, nickel, and cadmium are some of the metals used to form a protective coating. Metal spraying or metallizing is the surface application of molten metal on any solid-based material. It is possible to spray aluminum, cadmium, copper, nickel, steel, or any of several metals using this process. Parcolubrizing is a chemical treatment for iron and steel parts, which converts the surface to a non-metallic, oil-absorptive phosphate coating. It is designed primarily to reduce wear on moving parts. Anodizing is the most common surface treatment of non-clad aluminum alloy surfaces. The aluminum alloy sheet or casting is the positive pole in the electrolyte bath in which chromic acid or other oxidizing agent produces an aluminum oxide film on the metal surface. Aluminum oxide is naturally protective, and anodizing merely increases the thickness and density of the natural oxide film. Never clean with anything that could scratch through the anodizing and expose the untreated alloy. Aluminum wool or fiber bristle brushes are suitable for cleaning these surfaces. Alloydizing is a simple chemical treatment for all aluminum alloys to increase their corrosion resistance and to improve their paint bonding qualities. Surface treatments. Aluminum and magnesium alloys in particular are protected originally by a variety of surface treatments. There are several inhibiting materials that are particularly effective in the field treatment of aluminum, are beneficial to bare magnesium, and are of some value even on bare steel parts. Protective paint finishes. A good, intact paint finish is the most effective barrier between metal surfaces and corrosive media. The three most common finishes are a nitrocellulose finish, an acrylic nitrocellulose finish, and an epoxy finish. When a structure is chemically cleaned, the fade surfaces should be protected to prevent corrosive materials from seeping between the lap joints. This would cause corrosion to form in an area where it is hard to detect. There are two parts of sealing fading surfaces. The surfaces in contact and the edges where electrolyte, either chemical or water, could enter. Before starting any corrosion removal, you must conduct an inspection and evaluation of the suspected area. When you inspect for corrosion, you should follow the steps listed below. First, clean the area thoroughly. Second, if an area is suspected of having corrosion, visually inspect the area by using a magnifying glass. Third, to preclude metal damage, remove paint chemically from areas suspected of having underlying hidden corrosion. Use abrasive paint removal techniques only when corrosive products are observed. Number 4. After removing the paint, use a magnifying glass to determine the extent of the damage, especially if there is evidence of corrosion on critical parts. Corrosion cracks must be detected as early as possible. Step 5. Refer to the applicable structural repair manual for damage limits. Metal loss damage is accumulative. When assessing corrosion damage, consider prior metal loss, including areas on the opposite side of the part. Propellers and helicopter blades have critical balance requirements. Refer to the propeller and blade manuals that apply for evaluation and repair limits of corrosion, erosion, and abrasive damage. After the aircraft or aircraft part has been inspected, the extent of the corrosion damage must be correctly evaluated, submitted for applicable treatment, corrective action, inspection, and estimated time to return to service and or removed or replaced.